สวัสดีครับ Welcome to C and C++ language. Now we move to the Ep020. For this episode, I show you implementation gradient descent to solve the functions x power square root 3x minus 6 equals 0. From this equation, I show you to solve which uh, bisection method from the last episode 19. For here, there are the codes of the using the bisection methods. The bisection methods can solve this equation fine by have return the x value is 3. And now for this episode, we will change the method from bisection method to use the gradient descent. Now I introduce the gradient descent. The gradient descent is iterative optimization algorithm. You can use it to find cost or loss function. And for this gradient descent used for training inside the machine learning neural network by adjust the weight inside the neural network. And also you can bring gradient descent and hybrid with a genetic algorithm to improve the optimization algorithm. Here, what is the mechanism inside the gradient descent? From this picture, I bring from the internet. And here, this is an integer value. And then the gradient descent will do the derivative to find the path or waveform moving. Then when the gradients found which way is moved too low, it will change the next step moving until reach to the optimal point. Okay, the gradient descent you can search the code from the internet and I will show you the code. The code when you search is right here. This is examples. Use the cost functions and calculate x power 2. And for the function have the highlight here. This is doing the gradient. That means the gradient descent you should do the derivative function from the cross functions like this. This is x power 2 do derivative. This is 2x. And for this method, I don't use the derivation function, but I use the step on small step walkings. That is move very small step like this function here. That is f bar that come from fx plus h. H is a very small number. So we will use this method to create the function. Now we will start create the program. From this I use the source code from the last episode to improve. You can see and more detail from the episode 19. And here this is from the episode 19. Now I copy to the episode 20 from now. Here I check to compile the code and compile the code before modify. Okay, the code can run and say and show the output 3 for the results of this equation. But here this is a code of the bisection methods. The bisection method uses upper and lower move to the middle points. Okay, now we will write the code as the function this, but modify the code now. And the first step, we should write the gradient function here. But we don't do the derivative. We will use the small step walking. Here, this is a gradient, and we use the small step walking here. The function like this. Okay, now we write the function this. Yes, this is small step walking. For this, I write for this we should add the absolute value. Okay, now we will write the code at compete at the gradient function like this, and we write the code at the main function. And the main function we do the code like the example, right as the examples. So for all this code we will modify. We use the same variable names. Starts as 10. Now we will write the code in at the loop of the at the iteration loop, and the iteration loop is correct. So we should print out the checking the output. And now we calculate the learning rate. Calculate movement, not a learning rate. And then for here, I should keep the best results because of the example code not is don't provide the keep the best results. Okay, here for the best result, best I suppose it's 10,000. This is a base x and base cost. We should keep base cost. This is a cost from the function. Okay, now we write. I write the code to correct the base value. Don't forget change the x value to the here. This is an update the base results. The base results now print out the base results. I represent the iteration number. Okay. Save code. Now I think compete and check the code. Oh, a loss of error. X cost. X base. Okay, recompile again. Here this is a result, and for this I set as the 100 iteration. So start from the first iterations this is a 0 first iteration, and moving to the until to the best result at the 61 iteration, but the number have a problem for print it out here. This is a cost characters, very cost characters. Okay, and compile again. At the iteration 61, here get the the cost minimum as 0.0039, and the base value is 2.999993. This is a close to 3. That is the best results. Okay, now I will change by comment here and run it to the 10,000 iteration. Compile and run here, and at the best results, the best result as 82,000 iteration that's got a value 3, the x3. That is show the gradient descent can find the x value from this equation or the cost as here. Now I create cross functions by like this, and then I create gradient by use the small walking movement, and here this is the main function. I keep the base value and base cost, and here I set the 10,000 loop, and this is the main point for the program here to update. When you write the code, you should uncomment here to check the movement of grad value, because of sometimes the grad value is a move to 0. That is generate the not changing the output, and maybe you should change the moving step here and fine tune the number here to base the movement. Okay, here I think for this episode I show the code and write the code complete. See you the next episode. สวัสดีครับ